So this lesson that we're going to take a look at right now is going to deal with the volume of a sphere and hemisphere. Now we've taken a look at surface area already in the past, and now we're looking at volume of these shapes. And so a sphere and a hemisphere, remember, is a ball. And I'm just going to quickly grab mine so you can see it in the corner here. This is a ball, right? It has the round shape, if you want to kind of think of it that way. It's round, it's a ball, it is a sphere. The volume of that sphere is everything that is inside of a sphere. Okay? And now this doesn't have any kind of nice situations or nice ways of really finding it, other than if we come up with a strategy to kind of think of it as a bunch of pyramids. So what we're going to do to find the volume of a sphere, we're going to imagine that we have millions of little pyramids, kind of like this one here, that are combined into this sphere to make the entire sphere. Okay? And we're going to use that, and we use that to kind of figure out what our formula for a sphere is, the volume formula. Now, we're going to use if we think of it as a bunch of pyramids where the base area is our surface area of our sphere, then that's how we're going to come up with our formula. Now, without going into too much detail on it, I'm going to put the formula up here on the screen, and we'll see if it quickly shows up here. All right. So to find the volume of a sphere, we do 4 pi r cubed, okay, 4 pi r cubed divided by 3. In essence, it's the surface area of the entire sphere multiplied by the radius and divided by 3, because that's what we do with the volume of a pyramid. Okay, we're using the surface area of the sphere with the volume of a pyramid formula to come up with this as our volume formula. This is our volume formula, plain and simple. It's 4 times pi times radius cubed divided by 3. If you'd like to see how I derive that formula, we can gladly do that as well. I won't do it on the video as it takes up a little bit extra time, but if you'd like to see how it works, we can definitely do that. Let's find the volume of this sphere. So here we have a sphere drawn out. It has a diameter of 18 meters. So what this means is that we have a radius, r equals 9 meters. Okay, there we go. We have our radius. So we're going to use our formula with 9 as the radius. So our volume is equal to 4 pi r cubed divided by 3. We're going to plug in our value for r. Now, the radius is the only value that we actually need to find the volume of a sphere. So it's 4 times pi times 9 meters cubed divided by 3. Now, when we are doing those calculations, okay, this is going to be 4 times pi times 9 cubed. The 9 is cubed, not the rest of it, just the 9 is cubed, and then we divide by 3. Now, there's a couple different ways to do this here, and I'm going to put this onto the calculator here. Let's see, 4 times pi times 9 cubed. Okay, now I have a cubed, there's my cube. I use this here, x to the y and 3. If you look on your calculator, some of you have a cubed button, some of you just have x to the power of y. If you're unsure, we'll go through it in class as well to make sure that you're able to do that calculation. And then from here, we divide by 3. And we're going to come up with a nice big answer here, 3053.63. And so our volume, get to the next line here. Volume is equal to 3053.63 meters cubed. And again, cubic because it is volume. Okay, so cubic is because it's volume. Smooth that up a little bit to get it off there. So that's our volume. Again, it's just the radius. That's the only dimension that we need. We plug it into the formula and we come up with our volume. All right, the next one here is our Earth. We want to figure out what the volume of our Earth is. Now, our Earth is massive, okay? It is huge. So we're going to be getting a very big number, and that's okay. We have a radius formula or radius here. We're going to use our formula to find the volume of the Earth. So I'll put in the formula here again. Volume is equal to 4 pi r cubed divided by 3. Now again, because we're dealing with such a big number and we're cubing it, so we're multiplying it by like 6,000 by itself, it becomes really, really big. So volume is equal to 4 times pi times 6,371 kilometers cubed, and we're dividing that by 3. So again, we're going to get a very, very big number. I'm not going to do this on the computer calculator. I'm going to do it with my own calculator. So when I punch this in here, it's going to be 4 times pi times 6,371 cubed divided by 3. Now I want to show you something on here, and we'll see. I'm just going to make my screen or this video a little bit bigger so you can hopefully see. Here's my calculator. Okay, you'll notice something on this side. Okay, you see that times 10 to the power of 12. If you do this on your calculator here, you should see something like that. You're going to see a 1.83206,917 times 10 to the power of 12. What does that mean? Really, what does it mean? Okay, that is in scientific notation. Okay, and I'm going to put that number down here. Make this a little smaller so you don't see as much of me anymore. Okay, so this is 1.083206,917 times 10 to the power of 12. This is a number that's in scientific notation. It tells us that there are 12 decimal places between or we're going to actually multiply by a 1 with 12 zeros behind it. So when we do that, this is the number that we're actually going to get. We're going to get that the volume is equal to 1.083206,917. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There we go. There are, and now let's get some commas commas in there. Okay, kilometers cubed. That's the number. This is in scientific notation. This is in regular notation. We often do scientific notation because we can simplify it and make it a bit of a smaller number. We use that in kilometers cubed. We use this in math, especially when dealing with big or small numbers. So if you get a number like this on your calculator, this is what it represents. 12 is just how many spaces after the first digit. There's 12 spaces after the first digit. So that is volume of a sphere.